Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is binary matrix with maximum number of ones. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. So let's get started. Here is the problem statement, and it says that given a binary matrix containing 0 and 1 of order n cross n, okay, all rows are sorted already. We need to find the row with the maximum number of ones. Also find the number of ones in that row. Okay, so we are given a binary matrix and we have to find the maximum row which have a maximum number of ones. Okay, in case of a tie, print the smaller row number, and row number should start from 0. It is following 0 based indexing. Okay, so one example is given here. Let me explain the example. So I'm going to write example here, and I have n equals to 3 and I have a matrix of 3 cross 3. So it is going to have values like 0 0 1 0 1 1 0 0 0. You can see that each row is like sorted like 0 0 1. So once we have before, like I have 0 first and then 1. Even this is sorted, this is sorted. In this row you can see that like this row is something which is sorted, which is having the maximum number of ones 2. So what is the number of ones that I have? 2. What is the row number that I have? 1. So I'm simply going to return this as my output. Okay, but let me take one more case. If I have a matrix like 0 1 1 0 1 1 and 0 1 1, here you can see that all the rows are having two number of ones. So it's a tie, it's a condition of a tie. So in case of a tie, I have to return the row with like smallest index. So I'm going to return 0th row. So 0 and 2 is going to be my output. Now I hope you guys are clear with the problem statement, and let me now move to the solution. Okay, now first of all let me write solution here. So I'm going to write solution. Before directly jumping to any approach, let me talk about a concept which we are going to use in order to solve the problem. So we are going to use the same concept for every approach. I'm going to explain three approaches to solve the problem, and just the difference between approaches is of time complexity. Okay, so let me write one like array 0 0 0 1 1 1 1 1. Okay, you can think of this array as one of the rows which is present in the binary matrix. Okay, now if this row in this row, if I talk about this particular index, let's take I. So this index is representing the index of first occurrence of 1, isn't it? Okay, now this is something which is going to be special. How? Any element before this 1 is going to be 0 because it is sorted, and every element after this one is going to be 1 because it is sorted. So once I found the first like index of first occurrence of 1, then I can simply like n minus I to find the number of ones. Number of ones. So what I need to find is the index of first occurrence of 1. Why I am saying the index of first occurrence of 1? Because it is something which is easier to find in comparison to counting all the ones that I have. Okay, this is the concept which we are going to use, and let me now talk about the first approach that comes to my mind. Okay, so approach 1 that comes to my mind is linear search. How? If I have a binary matrix like 0 1 1 0 0 1 and 1 1 1, what I can do is I can check for every row that I have, that what is the first index of like 1. And once I found the first index, then I can simply find the number of ones, and then I can maximize that value. So what I'm going to do is, for every row, I have row here, every row here. So for every row is similar to I equals to 0 and I is smaller than n. So it is a way of traversing all the row. Now I will perform a linear search. So start a linear search. Linear search. Linear search for the first index of occurrence of 1. So for the like, let me write this as well. First occurrence of 1. Once I have found, so I will write the like number of ones by doing n minus I. Okay, it's not n minus I, it's like n minus j. After that, I will maximize that. Maximize. Maximize is similar, very simple. Like I will have a max which is -1 initially, and I will have a max index which is initially -1. So once I have found the like this number of 1 is greater than max. So if like number of ones is greater than like max index that I have, then I'm going to write max index equals to number of ones, and like max equal to number of ones and max index equals to I. Okay, so this is the first approach that I have. Like, let me talk about the time complexity of this approach. So for every row means I'm running a O of n loop, and after that, linear search is again O of n loop. So it is going to give me the time complexity of O of n square because of these two nested loops. Okay, now let me move to the approach 2. But before moving to the approach 2, let me give you an intuition that we are searching linear search here, and we are given sorted rows. So now you can think that why not to use binary search here instead of linear search. So now I'm going to write my second approach, approach 2, which is related to binary search. The profit of binary search is the time complexity that it provides to us, O of log n. Okay, so what I can do is I can check for every row. I can use the binary search in order to find the like first occurrence of index of 1. Then I will do these operations. So the term complexity of this is going to be O of n for each row and log n. Now how to find the index of first occurrence? So if you're someone who already knows it, then you can move to other part. I'm going to explain. I'm going to give you a brief explanation about this. So if I have an array like 0 0 0 1 1 1 1 1, in this array, as usual, I'm going to start from L equals to 0 and R equals to 1. So this is leftmost index, and this is okay n minus 1. This is rightmost index. So now I am going to start a loop like while my L is smaller than equal to R. Okay, why we do smaller than equal to R in binary search? Because L double equals to R is a condition for single element in an array. Like if I have single element, then L and R will be same. So in that case, I have to consider that case as well. Now what I'm going to do is I have two conditions. Either my current element is 0 or it is 1. So first of all, I will find the mid. Mid equals to L plus R by 2. Now the element at mid, if array of mid, element at mid is double equals to 1, or it will be equal to 0. So if it is equal to 1, what to do? Let me give you a case. So if it is like 1 here, so now this is 1. Okay, so it may be possible that this is the first occurrence of 1. So answer is going to be like mid, no doubt. After that, it may be possible that I have the first in occurrence of 1 at somewhere other index in the left, because I have to find the first occurrence. So I am going to move to left. So I am going to make my high like right as mid minus 1. So if I do right as mid minus 1 like here, so now my array becomes this, my search space becomes this. I have to like reduce my search space. Else now, else if my array like value is 0, if I'm here I have got 0 value, so in that case I have to move to right in order to find 1, because I have to find 1. This is my goal. So I will move to right. So I will make my low equals to mid plus 1. So when my low becomes mid plus 1, then I have this much search space. So I will make my like low as mid plus 1. This is how we are going to like use binary search in order to find the first occurrence. At last, my answer will be storing like the index of first occurrence. Okay, now I hope you guys are clear with the second approach as well. We are just going to put this binary search here in place of linear search. Okay, now I'm going to talk about approach 3, which is the most optimal approach. So let me talk about approach 3. This is the most optimal approach. Let me draw the matrix first. So I have 0 1 1 0 0 1 and 1 1 1. Okay, in this matrix my ultimate goal is to find this element. Why I'm saying this? Because this row is having leftmost occurrence of like 1, and it is going to have most like maximum number of ones. Let me draw one more matrix. If I draw another matrix, so like if I have a matrix like 0 0 1 1 1 1 0 0 1 1, like 0 0 0, after that I have 1 1 1, after that I have 0 1 1 1 1 1, after that I have 0 0 0 0 1 1, after that I have 0 0 0 1 1 1. Okay, here my ultimate goal, again I am going to say the same thing. My ultimate goal is to find this one. Why this one? Because this one is having the leftmost occurrence and current row is my answer. How to find this one? Let me tell you. I am going to start from this index. So my I will be equal to 0 and j will be equal to n minus 1. My I is row and this j is the current column. Okay. So if my matrix of I and j is double equals to 1, there are only two possibilities. Either this is 1 or this is 0. So I'm going to talk about both cases. So if my matrix of ij equal to 1, what to do then? If it is 1, then I'm going to move to left because I have to find the leftmost occurrence of 1. So there is a hope that I will find one more 1 in the left, and then if I find one more 1, then I'm going to move to left again. After that I'm going to move to left again. Why? Because I want to find the leftmost occurrence. So if my matrix of ij equal to 1, then I'm going to do j minus minus. Okay, clear. Now else, in the else case, what to write? Let me talk about this. If I have like if I have 0 here, so is there any possibility that I can find 1 anywhere in the left? No, because it is a sorted. So if I have 0 here, then I will have 0 here as well. Okay, now what I can do is I can move to next row, hoping that in the next row I will find 1, and if there is 1, then I will have 1 in the right part as well. Now there is 0, so there is no hope that it it will have more number of ones than this row. Why? Because if this is 0, I have 1 like in the previous row till this index, and if I have like the same condition, I have 1 here till this index, then again I am going to have but this particular row as my answer. Why? Because I have to, in case of tie, I have to give the smaller row as my answer. Okay, now I have 0 here, I will move to next row. So whenever I find any 0, I try to move to next like row. Okay, and at the next row, and I can see that I have 1 here. I have 1 here. So once I have 1 here, this means that this row is having maximum number of ones than all the row that I have already like traversed. Why I'm saying that? Because it has 0 here, it has 0 here, and it has 1 here. So if it has 1 here, it is going to have 1 in all the index previously. And if it has 0 here, then there is no hope that this number of ones in this row is greater than this row. So now I have find my 1. What I'm going to do is, whenever I find any 1 at any row column, then I store this row equals to I. This row is having the current row index, which is giving me the maximum answer. So this is how I am going to like find the number of rows. Okay, now once I have found this one, there is possibility that I can find more number of ones like in the below rows. So I'm going to move to left first of all, then left I have 0, then I'm going to move to next row, again I have 0, then I'm going to move to next row, again I have 0, I'm going to move here out of bound. So once I go out of bound for any row or column wise, then I'm going to like break. So while my rows like I is smaller than n and j is greater than equal to 0, because I am decreasing the value of j. So this is how I am going to solve the problem. Row is a variable which is storing the current answer. So this is how we are going to solve the problem. Even I have written the pseudocode in order to explain you what I am doing here. Now this is all about this problem. Let me show you the code now. Okay, so this is the code. You can see that I have written Java code here and C++ code here, and in the Java code I am making a variable I and j, 0 and n minus 1. Okay, now I have row equals to minus 1. While I am running this loop, this is the same loop that I have explained you in the approach. Like you can see here, the same thing I have written, and even here I have written the same thing. At last, my row variable is storing the maximum, like the row number which is having maximum number of ones, and n minus j minus 1 is storing the maximum number of ones that I have. How? Okay, so if I'm here, then I can see that once I have find the number of ones here, so I'm going to move down. I'm going to move down. Okay, so now this row is currently having index 0, and in order to find the first occurrence of 1, I have to increase this one. So I will have j plus 1, and after that I am just subtracting that j plus 1 from this n. So you can see here that I am doing n minus j plus 1 actually, but when the bracket opens, so if I write something like this is what I'm doing. J plus 1 is denoting the index of first occurrence of 1, is the leftmost index. Okay, so this is all about this problem. I hope you guys like the solution and the way I explained. Thank you.